Welcome to Excel online lessons. Today we're going to be having our first physics class. If you're here for the first time, please don't forget to subscribe, follow and share for other classes so that you can be notified whenever we post a new lesson. So today for our first physics class, we're going to be having our first topic of our syllabus, which is physical quantities. So we're going to be following the ZIMSEC syllabus for our learning. So our first topic is on physical quantities. So the first thing that you should be able to do when approaching this topic, you should be able to define or to know what a physical quantity is. So a physical quantity can be defined as any measurable property of a physical object. So digging deeper into this one, any measurable property of a physical object, we might be talking of something that can be measured. Let's take for instance, we're having an object. So the features of that object that you are being able to measure, for example, we can measure the object's mass, the object's length, force or velocity or acceleration. So all those that I have just mentioned, those are what you call physical quantities. So anything that you are able to measure on an object, we call them physical quantities. Now, these physical quantities can be expressed in terms of magnitude. When we are talking of magnitude, we are talking of size. Then it can also be expressed in terms of direction. Then I've just provided an example. Let's take for example a car moving with a velocity of 20 meters per second. So a car is moving at a velocity of 20 meters per second due east. So on our example there, the velocity is coming in as our physical quantity. Why? Because we have measured the velocity. We measured the velocity of what? Of the car. The car is the object in this case, and our physical quantity is the velocity. You see? Now, it is having a velocity of 20 meters per second. The 20 meters per second, it is giving us what? Our magnitude, the size of the velocity. So the size of the velocity is the magnitude of what? Of the physical quantity. Now going to the direction of the velocity now is due east. So due east is acting as our direction. So these are what you call physical quantities. We have so many physical quantities, but I just chose to give this as an example so that you get an idea of what you are saying. Now, after knowing how to define these physical quantities, we need to know the types of physical quantities, because we have two major types of physical quantities. So we have two major types of physical quantities. So on types, we have what you call base quantities. We have what you call derived quantities. So the base quantities, these are independent physical quantities. By independent physical quantities, I'm just trying to say they don't depend on anything. These are the quantities that we can straightly measure, or these are the quantities that we can be able to measure without doing any mathematical operations, or what we just need an instrument, then take the measurement. So these are what you call base quantities. So examples of base quantities can have length, we can have mass, we can also have temperature. These are what you call base quantities. They are independent. They don't depend on anything for measurement. These are what you call base quantities. Now moving on, we have what you call derived quantities. So these derived quantities, they depend on something. So they are dependent. They depend on something. So what do they depend on? So derived quantities, they depend on base quantities. We cannot have derived quantities without mentioning base quantities. So we can define derived quantities as products or quotients of other base quantities. So a derived unit, we can either get it by multiplying base quantities, or we can get it also by dividing base quantities. So the resultant answer that we get after multiplying or dividing the base quantities, that answer is what we call the base quantity. So when we talk of physical quantities, you cannot define a physical quantity without units. So here we have a list of base quantities and the symbol used, the SI unit, and abbreviations. So let's start at looking on base quantities. Now, the first example of a base quantity, we said we have length. The used symbol for the length is small letter L. SI unit is the meter, and the abbreviation for meter is small letter m. We go to the second one. We have mass. Mass, we use small letter m to represent mass. The SI unit is the kilogram, and the abbreviation is the kg. Small letter k and small letter g. We move to temperature. Temperature, we always use capital letter T to represent temperature. The SI unit for temperature is the Kelvin. We represent Kelvin with a capital letter K. We go to time. Time is also a base quantity. It is represented by a small letter T. The SI unit of time is the second, and the abbreviation for second is a small letter s. Now we move to electric current. Electric current is represented by capital I. The SI unit for current is ampere. Then the abbreviation for ampere is the capital letter A. We go to amount of space, is represented by small letter n. Then the SI unit is the mole, and the abbreviation is the mole, M-O-L, small letters. So these are what you call base quantities. So for the base quantities, we don't have to derive the units because we already have them, the SI units. But in derived quantities, we don't have the units initially, but we need to derive the units. So this is other type of question that comes under the topic physical quantities. They will always ask you to derive quantities, to derive units. They'll always ask you to derive units. So in exams, they always ask for the derivation of units. So let's start by listing our derived quantities. You should know derived quantities before you get to derive their unit. So let's have a list of derived quantities. Derived quantities. Derived quantities. Let's have derived quantities. So the definition, we have just talked about it. These are products or quotients of physical base quantities. So this is the definition for derived quantities. So let's have a list. So derived quantities, derived quantities, derived quantities. Now the first one, we can talk of area. Area is a derived quantity. We can talk of volume. Volume is also a derived quantity. We can talk of density. Density is a derived quantity. We can also go ahead and talk of force. Number 4, we can have momentum. Number 5, we can have pressure. So these are all examples of derived quantities, but they are not only 6 or 5, there are more derived quantities. But for practice, we're going to be deriving units for these derived quantities. So deriving units for derived quantities. Derived quantities. So on deriving units for derived quantities, let's start by listing a number of steps to follow so that we can get our answers easily. So step one, let's say step one, you need to write the formula for the derived quantity. This is the first step. Write the formula for the derived quantity. So this is the first step that you do when trying to derive the derived units or the derived deriving units. So step two. On step 2 now, you replace base quantities with SI units. Step 3, multiply or divide units according to formulas. Multiply or divide units according to formulas. Then that's it. These are the only 3 steps that we will need to follow to have our derived units. So I'm going to have solutions. We're going to have our solutions. The first one being the area. Solutions. Now, the number one is the area. Number one is area. So now, the first one is saying write the formula for the derived quantity. So the derived quantity here is area. What is the formula for area? The formula for area, it can be length times width or side squared. In terms, if it is a square, you can say side times side. If it is a rectangle, you can say length times width. So in this case, you can use the formula for a square. We can say s times s, side times side. But this base quantity, it is also our the side times side. These are all the side is a form of length, so you can say L times L. Now this L is a base quantity. The base quantity now you put it in square brackets. So it's length times length. They give us area. Now after doing that, we go to step 2. Step 2 says replace base quantities with SI units. So what is the SI unit for length? We discussed it earlier. The SI unit for length is the meter. You say times meter. So meter times meter is m times m. The multiplication of indices, you add the powers. There's a 1 there. So m power 1 plus 1, we're going to get it as m squared. So the derived unit for area is the m squared, the meter squared. So this is how we get our answer. So the derived units for area is the meter squared. Now moving on, let's go on and derive units for volume. Let's go and derive units for volume. This is our second question. Question 2, volume. Now I want to derive for volume. I'm going to follow those steps. So what does step 1 say? step 1 says write the formula for the derived quantity. So what is our derived quantity here? Our derived quantity here is volume. So on the volume, we're going to write V. V is our derived quantity. You put in square brackets and say is equal to. Now let's take for example, we're going to have a rectangular prism. So a rectangular prism, the formula for calculating volume for a rectangular prism, we're going to, or we could have a rectangular prism there. Could have it there. There is our rectangular prism. So what dimensions does our rectangular prism have? Our rectangular prism has length, it has width, it has height or breadth. So this is our rectangular prism. Now to calculate the volume for this rectangular prism, we're going to multiply the length by the width and the height. So it's L times W times H. So these are also base quantities. Length, width and height, these are base quantities. You also put them in square brackets. Now you come and say volume is equal to, now what is the base, the SI unit for length is the meter. You multiply SI unit for the width. Width is a form of length, is another name, it's a special form of length, so it's also meter. You multiply height is also length, you say meter. So V is equal to, now M times M times M, it means this is M is to the power 1, this is the power 1, this is to the power 1. So this is the same as multiplying indices with the same base. So you add powers, so it's 1 plus 1 plus 1. So V is equal to M power 3. So volume is the meter cubed. So we have just derived units for volume. This is how you derive units for volume. Let's go to the third question. We're going to derive units for density. Density. Units for density. I'm also going to follow our 3 steps. What does the first step say? Write the formula for the derived quantity. So the formula for the derived quantity here, density is equal to mass over volume. So D is equal to M over V. So D should be in square brackets, V square brackets, M square brackets. Now what is our second step? We're going to substitute these base quantities with their SI units. So we go ahead and say now D should be equal to the SI unit for mass. Earlier we said is the kilogram, which is the kg. We divide by the SI units for volume. We've just derived them is the meter cube, so it's the meter cubed. Now dividing these is very easy. Now kg divided by meter cubed is the same as kg multiplied by 1 over M power 3. So this one, now the kg is fine. Now let's convert this 1 over M power 3 using laws of indices. So the law of indices that is working there is of this form. Is 1 over A is equal to A to the negative 1. So this is the law of indices that we're going to be using to convert this 1 over M cubed to this form. So it is going to be like kg times, it's going to be kg times, so if we convert, so anything 1 over M power cubed, 1 over A is equal to A power, so this is the same as M cubed times negative 1. We're going to get kg times M power negative 3, because negative 1 times 3 is negative 3. So our final units are kg per cubic meter. So this is the final units for density. This is the final unit. This is how we get the final units for density. So this is how we get our answer. So D here is equal to this unit. So we're only just following 3 steps there. You need to know, first of all, you need to know how to calculate the derived quantity first. So we need the formula. The step 2, you just need to replace those base quantities in the formula with their SI units. Then the last part you multiply or divide the units accordingly. So for the 4th question, we're going to derive units for force. We're going to derive units for force. Units for force. Derive units for force. Force, the symbol is a capital letter F. We put in square brackets is equal to. So how do we get force? Force is equal to mass times acceleration according to Newton's laws. So we're going to look to dig deeper into this formula later in the physics course. So today you just need to know the formula. F is equal to mass times acceleration. Now F is equal to the SI units for mass is the kilogram, the kg. You multiply by the acceleration. Acceleration is the meter per second squared. Now F is equal to kg meter per second squared. So this is the derived units for force. This is how you derive units for force. How to derive units for force. Now lastly, we need to add some of our derived quantities there. On 6th place we can have velocity. 7th we can have acceleration. Then yeah, so let's have this. Now since we have already done the first 4 questions, now it's your turn to try out the remaining for momentum, pressure, velocity and acceleration. So you can pause the video and try to just go through the questions, then continue. Going to the next question, the 5th question is on momentum. So in this lesson today, we're only worried of the formulas first, the definitions and the derivations of these formulas. We're going to look at them later in the physics course. So the the formula for momentum, we can have rho being equal to mass multiplied by velocity. So this should be in square brackets, this should be square brackets, this also should be in square brackets. So going further, we're going to say our rho is equal to the SI units for mass is the kilogram, multiplying by those for velocity is the meter per second. Now rho should be equal to kg meters per second. So this was an easy one. This is how you get the derived units for momentum. Going on to pressure. So the formula for pressure is P is equal to force divided by area. So this is force divided by area. Make sure to put in square brackets and square brackets. Then we go ahead and say, now for our pressure, we're going to say it is equal to our force The units for force, remember we have just derived units for force is the kg per square second, kg meters per square second. Now you divide by the area, sorry for that, you divide by the area. Area will also derive the units for area. We said the units for area is the meters squared. Now we do the math. You say kg multiplied by m power 1 over m power 2 multiplied by s power minus 2. So this is the math here we're going to just solve. Now kg, so m to the power 1 divided by m to the power 2, these cancels are going to be having m there. So it's kg 1 over m multiplied by s power minus 2. So we're going to have kg. So 1 over m, we use that one, the law of units. Let's say 1 over a is equals to a power negative 1. So this is what you're going to use. Kg per meter. This is per meter per second squared. So this is the units for pressure, or it can also be called Pascal. This is the Pascal. So it's kg per meter per second squared. So this is how you derive units for pressure. So having done that, you're going to look at, you're going to take the 6th question and the 7th question as a takeaway so that you can have more practice. Having said that, this is all about physical quantities. You just need to know that physical quantities, the definition, the types, the basic quantities, then you go to the derived quantities. Now, after knowing that, you need to know the examples, SI units, and on derived quantities. You need to know how to derive. You just need to know how to follow these 3 steps that I have just listed there. Then you are warm and dry. So until next time, it's a bye-bye for now.